This video is going to show you how to locate the epicenter of an earthquake. At this point, you're going to want to take out your notes because there's a couple things that I'm going to have you jot down as we go along. This is something that I would put in your notes if you don't already have it. So at this point, we've learned how to do two things. We've found the lag time, which is the difference in arrival times between the P and S waves. In short, it's the S wave minus the P wave. So we've spent some time looking at times and you've subtracted them and you've been able to find the lag time. That was the first step that we did in this whole process. Then we moved on finding the epicenter distance. What we were looking for is each time that you did the activity like this, what we were really looking for is we were trying to figure out how far away did that earthquake start. So for example, if we were to feel an earthquake in Cleveland, Ohio, they could use this method and determine that the earthquake was a certain distance away as far as the epicenter was concerned. So for example, if you got 2,400, we know that the earthquake started, which is the epicenter, about 2,400 kilometers away. And that's what we've been working on as far as epicenter distance. If you don't have in your notes, please make sure you jot down that the epicenter is the location on the surface where the earthquake starts. So at this point, you've learned how to do lag time, you've learned how to do epicenter distance, and if you're struggling with either one of these, there's videos available for that. This video is no longer going to teach us how to do these two, but now we're actually going to identify the exact location of an earthquake, or the epicenter. Here's a table that shows 3 different cities that felt an earthquake. So an earthquake occurred in Los Angeles, Mexico City, and Hershey, Pennsylvania were all able to feel this earthquake. This does not mean that the people felt it, but the seismic stations were able to detect it with their seismograms. Here is all of the data provided. So we know at each city when the P wave arrived, when the S wave arrived. I've already done the lag time for you. That's what we've been working on. And I've also used this method of finding that last column right here, which is the epicenter distance. With this information, we'll be able to identify exactly where the epicenter was located. So what we need to do for this is you really need to make sure that you pay attention to this last column right here. This is the column we're going to use in order to find this information. The first one we're going to start off with is Los Angeles. Here, it tells us that the epicenter distance was 1,600 kilometers away. So what we do at this point is you have a map, and on your map, each of those 3 cities are identified. Los Angeles is here in red, Mexico City here in blue, and Hershey, Pennsylvania is in green. Remember that the first number we looked at right here was 1,600. So what I'm going to do is I'm going to take my compass, I'm going to put the pointy part on 0, and it's really important you're as accurate as possible with this. When I look at this scale, I have here that each of these lines is going up by 100. So for the first number, I want 1,600. So I'm just going to move to make sure I'm as close as possible. I am then going to move the compass so that the pointy part is in the middle of that city, so Los Angeles. At that point then, what I will do is I'm just going to draw a circle. Now what this means, Los Angeles felt the earthquake. They know that the epicenter is 1,600 kilometers away, or 1,600. That means the epicenter is somewhere on this red line. So as you can see, that's thousands of locations that it could be. So that's why we need 2 other cities to help identify exactly where it's located. So the next city I'm going to look at is Mexico City. If I look at this data, it says the epicenter distance is 1,200 kilometers away. So what I will do is the same process. I'm going to bring my compass down to the scale. I'm going to put the pointy part on 0, and this time I need to move it to 1,200. Again, making sure you are as accurate as possible. I then move the compass to Mexico City, and I'm going to very carefully draw a circle with my compass. Now, the last city I have is over here at Hershey, Pennsylvania. So I look at the data, and this one says 1,700. So what I do, again, is the same process. I take the compass down, pointy part on 0, and I will move my compass so that it is at 1,700. Then at that point, I come up here, I put the pointy part in Hershey, Pennsylvania, and I will simply draw my circle. So if I actually back up here for 1 second, if we look just here, if you just have 2 seismic stations, you now have been able to narrow it down to 2 locations. So what this means if you have 2 circles is we know that either the epicenter is here, where these 2 lines cross, or it's up here. This is why we need a 3rd seismic station. So when I do this circle, I now see that all of these circles only intersect in one spot. That means that the epicenter, or where the earthquake started, was actually right there where I put that little star. That means that the epicenter is in northern Texas. So the earthquake originated here, and it was able to travel to all of these locations. This is something really important that I think you should add in your notes. Here it is in writing. You might want to pause the video to do this, but one seismic station will show you how far away the earthquake epicenter is, not direction. 3 seismic stations show you exactly where the epicenter is. And I think this little diagram here is very important. And for those of you that are visual, might need to add that. Finally, when you look at this map, you can tell just by looking at it who was closest to the earthquake and who is farthest away. Closest to the earthquake would be Mexico City. As you see, the circle is the smallest. And then when you get between Los Angeles and Hershey, Pennsylvania is the one that's actually the farthest away. And we can even do that by looking at our data over here. But that might be something else that you want to add to your notes. So again, you need 3 seismic stations in order to find the epicenter. And it is super important that you're as accurate as possible with your compass and all of your measuring.